Let us solve for the minors and cofactors of matrix A for this video. The minors and cofactors are interrelated to one another. They just differ on specific entry in the formula. And these two are very important as we move further on the topics on adjoint and other topics concerning determinants and matrices. So let's start with the minors, because we will start with the minors before we'll go to the cofactors. So the minors are determinants of submatrices that will be formed when a certain entry is chosen and all the entries on the same row and same column of the said chosen entry will be disregarded. So let's start with the minors. Label for minors, of course, M. Our entries here, this is our 1, 1. This is our 1, 2, 1, 3. Meaning first row, second column, third column. This is our second row. So first column, that's 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Please make sure to be reminded of that nomenclature. So we'll talk about the first minor of 1, 1. This means we are going to remove this column and this row, as these are the first columns and rows. Whatever is left here, this will be the submatrix. And this is where we are going to solve our determinant. And that determinant is the minor of 1, 1. Okay? So it would mean, again, we will just consider this matrix here, because we remove this and remove that. So we'll have the determinant AD minus BC. So 7 times 4 is 28, minus 1 times negative 1 is negative 1. So the first minor, or the minor of 1, 1, is equal to 29. Okay? This is the first minor. Now, let's proceed to the second minor. Or that's not necessarily first or second, but minor 1, 2. Minor 1, 2 is now the first row, second column. Remove the first row, remove the second column. What remains would be your submatrix. In short, 6, negative 1, negative 3, and 4. And you take its determinant. Okay? So it would mean like this. 6 times 4, that's your AD. So that's 24. And then you will have negative 3 and negative 1. So minus 3. So you will have here a result of 21. Positive 21 for your minor 1, 2. Next, minor 1, 3. Remove this. Third column, first row, and get the determinant of the submatrix. 6 times 1 is 6. Then you have minus 7 times negative 3 is minus 21. So the result here is 6 plus 21, 27. Minor 2, 3, meaning second row, first column. So you have negative 2, 3, 1, and 4 for your submatrix and get its determinant. Negative 2 times 4 is negative 8. And then 3 times 1 is 3. So minus 3. That's how you will have a result of 11. Minor 2, 2. You will remove this cross here. And you have 1, 4. 1 times 4. So and then you will have 3 times negative 3. In short, you'll have 1 times 4 is 4. Minus 3 and negative 3. That's actually minus 9. So double negative property, you will have 13. Minor, oh, sorry, my bad. I'm so sorry. This was actually 2, 1 earlier. 2, 1. If you have noticed that, and then it's good. Okay. I am correcting it. That's 2, 1 earlier. So 2, 1. 2, 1. So you have negative 8. Yeah, that's correct. I just labeled it wrong. So you will have your equal to, again, 2, 3. 2, sorry, my bad. Second column, a row, and third row. So you have 1 and 1, negative 2 and negative 3. So you will have 1 times 1 is of course 1. Negative 2 times negative 3 is minus positive 6. So you will have negative 5. Minor of 3, 1. So you will have to remove the third row and the first column. So that their interest that remains would be your submatrices. Submatrix rather. Negative 2 times negative 1 is positive 2. Then 3 times 7 is minus 21. So you have a result here of negative 19. Next, minor of 3, 2. So 3. So remove this 3 and that here. So you have 1, negative 1, 6, and 3. So 1 times negative 1 is negative 1. Minus 6 times 3 is 18. So you will get negative 19 as well. And finally, for minor of 3, 3, you will have row 3, column 3. Okay? So that's 1 times 7, that's 7. Sorry. 7. And then 6 times negative 2. So minus negative 12. Double negative property, you will have 19 here as well. Now, these are all for the minors. Okay? Next will be the cofactors labeled as C. So cofactor 1, 1, cofactor of 1, 2, 1, 3, 1. So you have cofactor of 2, 1, 2, 2, 2, 3, then 3, 1, 3, 2, and then 3, 3. The cofactor will use the result of your minor. Minor of entry, a sub 1, a 1, 1, etc. The cofactor will just have this additional formula. Negative 1. So you have formula for the cofactor is you have ij is equal to negative 1 I plus j times the minor of your ij. So you will have to add the assigned column and rows. So you have 1 plus 1 times the minor of 1, 1, which is 29. Having an even exponent will make our negative 1 positive. So the cofactor of 1, 1 is positive 29, the same as its minor. But here comes the difference. For your 1, 2, so you have 1 plus 2 times 21. Take note that this is odd, so the negative sign will retain. So instead of positive 21, you will have negative 21. Notice the difference of the two. So they are not necessarily the same. Next, so negative 1, 1 plus 3, that's even, right? So it's still 27. Here, we have 2 plus 1, that's odd. So you will have, by the way, negative 11 earlier. My bad. I forgot to put negative 11 earlier. Okay. So I was thinking it was 11. So here would be 11. This time, negative 11. Because of this, becomes negative. Here, you will have negative 1, 2 plus 2, and then times 13, that's even, so it stays positive 13. Next here, you will have negative 1, 2 plus 3, so that's odd, so negative of 1, and then times negative 5, you will have positive 5. Next here, by the way, you could also place parentheses if you would like to. I'm just going to place parentheses here so that we would have the same process involving negative results. Negative 1, 3 plus 1, that's even, times negative 19, so it stays negative 19. You have negative 1, 3 plus 2, that's odd, times negative 19, so it returns to positive. Then negative 1, 3 plus 3, that's even, times positive 19. The result is a positive 19. So this is how we solve minors and cofactors of a specific matrix. So again, the difference of the two is this expression as a whole. And these are very important for our next topic. Thank you very much for watching.